Who remembers what the product rule is? If I have f of x times g of x prime.
G prime times f of x, or g prime of x.
Derivative of the first.
Answer.
I'm so lost. One at a time.
Same. Derivative of the first. Copy second.
I'm just writing.
Is
this
vice versa?
Okay, we should probably write it different.
Copy second.
You're just telling me, okay, so we have f prime of x, g of x, plus f of x, g prime.
Okay, this microphone's really messing
It's echoing
Huh?
right there.
It's echoing like really.
You have your
Oh,
speakers
the
back
speakers
here.
are up, sorry.
Don't say anything.
Can't you just know that I like to hear my own voice? And then you go,
And then you get mad at us for playing games.
there's a different level
yeah?
right there. I mean, I still get 6 hours of sleep a night, which is not enough.
I mean,
Okay. I write it this way with f prime and g first because the quotient rule is very similar, right? So if we got the product rule, we can write the quotient rule, f of x over g of x prime. It's low d high, so minus high over I had to slow down because I was going to write something wrong. So over the square of what's below. So notice the top and the product rule and the numerator here are the same except the sign. It kind of reduces your workload on memorization if you kind of compare those two a little bit. And just remember the quotient rule as the denominator, it's a quotient. Okay, so that's a little tip. I think I relayed that last year or 2 years ago to you, but who knows? Okay. Let's see.
That's taller than I heard.
What?
Did we put Charlie Brown in that theater at one point?
You bet it was that
You
big.
deserve that.
John Smith was Charlie Brown.
I don't watch it.
Oh man, that's
It's like a match made in heaven.
Yeah, seriously.
Please, if I actually start watching
She sat right there in Cal PC.
Was it Avery?
And her name was Alcia Rona. I think was Snoopy.
Yeah.
Yeah.
I'm doing Annie this year, and I told
God, that was fun.
Hunter that
That
I
was a long
wanted
time
him
ago.
to
It
be
was 4 years, 5 years.
3 or 4 years ago.
Easter War Bus.
Yeah.
Sure.
Do you? Okay, so let's just do a couple of quick examples and.
We can get us our homework to finish.
Well, could you write down the homework so we can start on that if we don't want any examples?
You know I could,
Yeah.
I like that.
but I'm not gonna. There's that little Google Classroom too that's been posted on for a week.
Yeah, it's been posted every
Like-
week.
That's a waste of batteries.
Okay, product, right? Identify the product. What's the derivative, Canyon?
Let's see. Oh, okay, so that's e to the t times 2t
Send you a picture just
plus e to the t times
What's the derivative of an exponential?
Yeah.
Oh, do we
Oh,
remember?
Yeah. Sorry. It's that. It's.
Is that right?
yeah.
Yeah, I kind of threw that one at you, so now you might want to actually pay attention, huh? Okay, so remember, yeah, the derivative of an exponential. It's not going to be on the assignment, but you might want to pay attention now. I don't even know what section that's in, to be honest with you. It's somewhere back here behind.
Oh, we saw that in flashcards.
Yeah.
Is it, so did I do it right?
I think so.
'Cause I've only been doing calculus for like 15 years.
Yeah.
And I do mix things up.
No,
once in a
you
while.
did it right.
Okay.
Only 15%.
And then you can, if this is multiple choice, you might see it written like this. Okay, be careful, right? Because you can factor those two items out. Right, so just be aware that might show up on a problem. The AP, they have their little fun. And,
Maybe all of us.
okay, I'm going to show you a harder example. That's why you might want to pay attention. Okay. How many of you know anything about electricity?
I know.
Not mess with it.
Okay, if you're going to be an electrical engineer, which none of you are, this is going to be really important for you.
I know.
Do you know anything about resistance? And not the Antifa kind. I'm talking about the battery kind.
Well, technically I have a younger stepbrother, but you want to like.
Okay. The variables in, so when you have an electrical current, it doesn't just flow freely. There's resistance, right? There's impurities in the copper wire that resist the flow of electrons. When you get in the battery, there are different impurities or different materials that impede the flow of the electrons for the battery to work, okay? So it reduces the power flow, and you have to put that into your calculations as an engineer in order to make the power or the battery big enough for the laptop per se, okay? Or to make your wire big enough for your subwoofers in your car when you hook, wire your sub in. You have to take all that into account, okay? We have a voltage. The variable is V. The resistance. The variables R. And the power delivered. Is big R, which I don't know why. Here's the formula. I think the output power, they define. Yeah, the output power, P equals V squared R over R plus R squared.
Have you ever taught physics? Would you teach physics if someone asked you to? You have to talk physics.
If I don't know, I'm kind of partial to wood shop. Something would have to give.
Your time period. That's what you would give up for.
No.
For what?
What would you give? Would you give up
2
free calc?
letters, 1 word. No.
Would you give up free calc?
Yes.
I don't
I don't know, it's kind of a tough call because I get to prepare you guys for calculus.
Have physics.
Okay,
No,
calculate if wood shop ended, like if we needed to hire a full-time shop teacher, I would consider highly taking on AP physics. But Mr. Will does a pretty good job. Don't be dull. I've never sat under AP Calc class or physics class, so I don't know, to be honest with you. Okay, calculate dPdr, assuming
Yeah.
V and
Well, physics is pretty much just an application of calculus, for the most part.
We're taking algebra.
if you do true physics,
Yeah, well,
calc-based physics, My mind works a little bit more on the application side than when I was your age. Okay, so here's a key phrase. We're going to calculate the derivative of p with respect to r. That means this is our derivative variable, right? Assuming that v and r are constants, so we're going to consider them basically numbers, right? What are we actually calculating here? Yeah, it's the derivative, but what does it mean in context of the battery?
Electricity.
Huh?
Flow of electricity. How quickly
Power delivered.
Remember, derivative is a rate
So this is the position.
at which the resistance is changing compared to the output power, right? So again, be able to quantify that. And all you're doing is saying it's a rate, and then you're comparing the two variables. Okay, so dPdr is it's a quotient, right? Because we got big R's on top and bottom. Yeah? So what's the low and the derivative of the top?
But V is the constant.
This is a number, basically.
Just say
So shouldn't it just be V squared?
V squared. Yep. Minus pi times d low. Jansen, man can move a mountain. That didn't just get recorded to YouTube. Is this a chain rule issue? What's the derivative of r? 1. What's the derivative of little r? 0, because it's a constant. Right, so this is not a chain rule issue. It's just a power rule. Over the square, what's below? Right?
Shouldn't it be the 4?
yeah.
No, that was really messy.
I wasn't done
R
yet.
plus squared squared.
Okay. All right, so kind of messy because there are so many variables, but just think of those extras as numbers and we're good.
I feel like it wouldn't be as messy if they were like actual numbers and weren't letters. So changes and stuff.
Those are numbers that you just want to know.
Where is that tangent line horizontal?
Yeah, when the that is 0, isn't
Yep. So dPdr equals 0, huh? That's what you say. Where does that occur?
I'm sure you're gonna tell us.
Well, do we need to consider the denominator?
No.
No, right? Because that would make it undefined. What about the top?
I don't want to consider the top. But
Considering little r and v are
Yeah.
constants. Okay, this is a number. Is it ever going to be 0? So v could be 0, right? That's an option. But voltage is 0, nothing's happening. There's no power, right? So it's pointless to consider v equals 0. If we're thinking in context. How would I make
Jim, those
this
totally give us a problem like that.
and this 0? Because setting an equation up, we can do that. Let's try it. Those have to be equal to each other, right? Set that equal to 0, add 1 over. Okay, how can I start manipulating this? Oh. right? There's one variable gone. So what we're left with? Okay, we can divide, right? Subtract R, you get when big R equals little r. That would make
It makes me really sure.
how's that gonna work?
Yeah, because that doesn't,
No, it does. Because if, constants, those would be the same. This is throwing a wrench in our works. What am I doing wrong here? That's what we're doing wrong?
Is she sub here yet?
Yeah, she's up to the special.
No, that's right.
Not that PE.
Where did that 2R go in their equation?
What? Why do we gotta do that?
Oh, they just did it differently. It's good. So, the other way to write this is R minus R equals 0, right? If these are equal, you get subtraction to get rid of it, which is 0. Okay. There you go. So we're thinking a little bit in context. When the resistance, right? What were the variables? Like it's been 5 minutes. Equals the power delivered is when that rate is not changing. Right?
well, that makes sense.
So again, I'm going to show you some harder examples this year, right? So not worthless all the time to pay attention, but I know you can do these. Just in practice. Here is 3.0. Prelims,
You get prelims?
1, 2, 3, and then exercises.
I fold this paper right there, right way.
Whoops. Yeah, apparently I think they're important. 40 and 2, 8, 10, 12. What's even?
Remember last year when we got like 3 homework assignments in a row that had no?
No, I don't remember that. Okay,
Give us like one.
you got 15 minutes at least, so give it a shot. Maybe you can get some of it done.